Did you all like the pizzas? Okay, good change of taste, right? Yeah. All right. But if you like that, then you like what we have tomorrow. You like it much better. But that's a secret, so we're not gonna reveal that secret. Okay. Any guesses what we're having tomorrow? Oh. So he guesses steak and lobster. We're sorry, we cannot afford that. Yes, but any other guesses? Second guess? Yes. Sorry? No, not there yet. Okay, we'll see it tomorrow, right? So I'll leave it at that. Okay, for our power hour today, we have Anish Roy, and he's here to share his journey from being a participant in with Cyber AI Camp from 2024, and now being a student instructor in 2025. And he's done a couple of very interesting things in research. So we're going to see his entire journey, how he took this experience. He was one of you last year, right? How he took this experience and how he applied it after this camp, and what kind of results he's got. Okay, some amazing results. So we'll hear from Anish now. So the stage is all yours.
All right. Hello, everyone. I'm Anish Roy, and I will be talking about my journey from WITH 2024 to 2025. So I'll first talk briefly one slide about myself, and then we'll move on to my experience last year in the same summer camp you're attending right now. Then I'll talk about the background I had in research last year before I started working on anything, and then I'll move on to my first research work, which is about wildfire detection. Then I'll move on to my second research work, which is demand response prediction in smart grids. And then I'll talk about research that I'm currently working on, and I'll wrap up my talk. So, about myself. So I'm a rising junior in high school, not in college yet. So, any rising juniors here? Rising juniors? Nice, nice. So, rising junior in Archbishop Mady High School. One fun fact about me is I was born in South Korea. I lived there for almost 9 years. Things that I like to do: math, coding, research, and chess. For math, I do a lot of competitions. Most important one being the AMC 10, and I've qualified to the AMI twice with distinction. So a lot of math I've been doing. Coding, I do ISOCO, I do machine learning coding, I do a lot of coding as well. Research, which is the topic of this presentation, I'll be talking about research a lot. And chess is, right now, it's just a hobby. When I was like 7 years old, I represented Korea in the Asian Games. So I used to be like an international level chess player. Right now it's more or less just a hobby I play online. I have 2 IEEE conference papers, and right now I'm a research assistant at San Jose State. So, talking about the camp last year. So I attended this camp last year. It was a pretty good camp. It was actually a little smaller. We have like 2 classrooms this year. Last year we had only 1 classroom. So I'm glad to see that it's growing, and this made my interest go into cybersecurity and research. And this has encouraged me to do a lot of research in many cybersecurity topics. So I attended this last year. We had the Raspberry Pi, in fact, instead of the Jetson device you're using now. And it inspired me to do some work with the malware, which malware is basically malicious software, which can be like any file or anything that is designed to corrupt your laptop or any of your devices. So I'm currently doing some work with malware images, which is something I'll mention towards the end of my presentation. Yeah, my research is ongoing in malware classification. So yeah, this camp is a great camp. They introduce you to a lot of new topics. You can meet a lot of guest speakers. Yeah. And last year I remember making friends as well. Made a lot of friends. Some of them I in fact stayed in touch with. Even now, in fact, I recently studied with one of them for AP exams. So a lot of nice friends. Glad to see you guys are making friends as well. And hopefully this camp gives you the same level of experience as it gave me. It's a picture of last year's camp. You can notice me towards the front. I'm pretty sure this was not the whole camp. There were more people as well, but this is one of the pictures. So yeah. Yeah, as you can see, a lot more people right now, so camp is growing, and it's nice to see that. Food is better this year as well, so I'll say that as well. All right, now I'll talk about my background in research last year after the WIT Cyber Camp. So a lot of my research, in fact, all my research until now has been done using machine learning, deep learning to be specific. But I was only introduced to machine learning 1 year ago, and to spark my interest in it, I found it a very nice topic, like a machine being able to predict something that it hasn't been given data for yet, sparked my interest a lot. So like the background I had for machine learning is that I learned the theoretical side of machine learning through Indra and Jean Coursera, so it's like a course in Coursera. Forgot the exact name, but it's taught by Indra and Jean. He's a very popular guy in the machine learning world, and he does great videos that you can see. Nice assignments, very, very doable assignments and quizzes, and I completed the course decently fast and got the certificate, and that is what introduced me to very basic aspects of machine learning, the theoretical side, not the coding side. So in order to code machine learning, I actually watched YouTube videos, which is also actually seemingly a very popular thing that is done nowadays to learn machine learning, deep learning. Just watch, there are many great YouTube videos available. The channel I watched was called Code Basics. So if any one of you wants to learn like basic machine learning coding, I would definitely recommend Code Basics. It was a great channel. Introduced me to a lot of simple models, and yeah, it was pretty good. And then after learning basic machine learning coding, basic machine learning meaning like linear models, like not deep learning, linear models like linear regression, logistic regression. There are many linear models available, most of them through like scikit-learn library. But after that, I gradually learned deep learning, the theoretical aspect, and the coding aspect. So that was my background last year in machine learning. So to code deep learning models, or any model, in fact, we first gather data. Depending on what project you're doing, the data will obviously be different. Pre-processing is, then after we gather data, we pre-process the data. So in data pre-processing, it's basically making the raw data, making that data like available to be put into a machine learning model. So to give some examples, pre-processing would include handling like NaN values. So like if there's a column in the data set which is like filled with blank empty values, you want to remove them because otherwise the model will get confused when looking at those entries. Another part of pre-processing includes removing outliers. Outliers may like confuse the model as well, and it may deter the model's performance. So we want to remove outliers as well. Another part of pre-processing is scaling the data, which is when you make like very large values, like you basically make them smaller. Sometimes you want to make them follow a normal distribution. That is just so that like model typically does better with scaled data than unscaled data due to large values. After you pre-process the data, so those are like very few examples of pre-processing. There are many examples of pre-processing, just named a few of them. After that, you build the deep learning model with TensorFlow, PyTorch. If you want to do a simple model, you would typically use scikit-learn. There are obviously other libraries available, but scikit-learn is probably the most popular amongst the simple models. So I use TensorFlow, but you can also use PyTorch as well. PyTorch is also very common, and I've heard it's pretty good. TensorFlow is a little older than PyTorch, but I was introduced to deep learning with TensorFlow, and I just stuck with it. So after you build the model, you have to train the model and test the model. And then test the model, you basically give the model unseen data and you see how well it's doing. You can evaluate accuracy, like how much it's getting right, and you can evaluate a lot of other metrics as well, but accuracy is definitely the most common one. And the last step, which is actually probably the most important step, is hyperparameter tuning, in which you change a lot of aspects in your code. For example, if I use like 5 layers in my original model, then I want to experiment with 4 layers, with 6 layers. So just changing up like a lot of parameters in your code to see which set of parameters do the best. And you want to use those results in your research and in your work. You want to get you want to get the best results possible. So that's why we tune the hyperparameters to see which set of parameters does the best. There's typically going to be like one set of parameters that do better than the others. Some sets of hyperparameters won't work as well, so you have to be careful on the tuning there. So a little bit about the co-researcher that I have been working with. So I did my research work with another person. She was supposed to be here today, but she unfortunately could not make it. She works in NVIDIA, and this is how we met. So in October 2024, there was a hackathon hosted by my school's computer science club, and that hackathon was at San Jose Public Library, and I think it was at Martin Luther King Jr. Library. So we met over there. She was a judge, I was a participant. So after the hackathon and after everything was over, I connected with her and we kept in touch since then. At April 2025, we hosted a boot camp after like a lot of preparation and work. That's I won't be talking much about the boot camp right now. Again, also in April 2025, we presented together in IEEE ICMI, which is a conference. It was online. It was hybrid, so we presented online. That presentation we both did together. In June 2025, I presented alone in IEEE SUSTech, but the research work was done by both of us. So both of us did all the work together, all the work that I'm about to talk about. We did that together, and this has been our timeline. So we first met in October 2024, and we're still in touch today, and we've done 2 research works together. Yeah, so to understand about my research, you should know about CNNs, convolutional neural network. So it's a type of deep learning model. It is typically used for image data. So they're usually with deep learning models, they have their own specialty, and for CNN in this case, it's best for image. It can also be used for text as well and for video. It's actually pretty good for video stuff as well, but it's really much used for image data. This also comes, CNN is also involved in like higher level architectures, not just deep learning, but also like GANs and like other higher level machine learning stuff. CNNs are used a lot. CNNs, in a nutshell, they use filters to detect patterns. There's an image in the like bottom right corner if you want to look at that. It uses filters to detect patterns in the images, and it is my personal favorite model because it was the first deep learning model I have used, and I've used this in all my research until now. So yeah, CNNs, a little bit about CNNs right here. So the first, when I met my coworker, it was at a hackathon in October 2024. So in fact, our first research work was just an extension of the work I did in my hackathon. So in the hackathon theme was very broad. It was just like use AI for sustainability and healthcare. So I chose sustainability, and the problem I saw was wildfires, which happen quite frequently, especially in California. I hear at least every year or sometimes every couple of months that there's been a wildfire somewhere near LA or something, and it has caused a large amount of damage. So that was the problem. And the solution was to use machine learning to quickly detect a fire given an image, which would help put out the fire before it does much damage. So a lot of satellite images are being taken, so if we like apply machine learning to those images and we detect a fire quite quickly, then we can stop it before it does any significant damage. So that was the solution I thought of. More about that on the next slide. Also, again, so we're using satellite images as our data, so obviously CNNs would be like a great tool to use here. So this is our first research work, which we published, or it's actually under process for publication, but which we have presented in IEEE ICME ICMI 2025 in April. So this is some details on our solution. So our input, we cropped it, which is also part of our pre-processing. We cropped it to 224 by 224 pixels. We did this because we used transfer learning models, which I'll get to later. The task was binary classification to predict wildfire occurrence. So we either predict there is a fire going on or there's not a fire going on. So it's one of those two choices. That's why it's binary classification. The dataset split, we split it into 70% testing, 15% validation, 15% testing. So you already explained training data is used to train the model to make the model understand which images like have fire, which don't. Testing is used to evaluate the model's performance, accuracy, and how it's doing basically. What validation basically does, validation is technically part of the training data, but it essentially ensures that the model isn't being trained too specifically on the training data. We want to avoid this phenomenon called overfitting, and in overfitting what happens is that the model gets trained specifically on the training data, and it doesn't work for anything outside the training data. So the model's like too much focused on the training data. So the validation data, what it does is that it basically validates that the model is not overfitting, that the model is performing as it should be, rather than like being trained to specifically do right on the training data and like do completely wrong on all the other data. So the architectures explored were LSTM. LSTM stands for long short-term memory. That's a model that I tried out. It's not great for image data, which this experiment would prove also. Also, we had a CNN model, which is what I explained like in the previous slides. Convolutional neural networks, great for image data. And then we also used pre-trained models, pre-trained ResNet 50 and DenseNet 121. So pre-trained models are so these pre-trained models that I used there are called transfer learning models. What they do, basically, they're already trained on a large data set. So this data set is called ImageNet. So these two models are trained on this data set called ImageNet, and they're already trained to like get patterns from images. And then after we train them, so they're already trained on this huge data set called ImageNet, and then after that, we train them specifically for our data, in this case, wildfire data. And then they typically are expected to do well, better than normal convolutional neural networks, because they're already trained and they already have the capability to detect patterns within images. So yeah, details about our training is like we use loss function called categorical cross entropy, atom optimizer. We won't get into details of that. So the number of epochs. So by the way, for context, each epoch is basically the model going through the entire data set once, and forward propagation and back propagation, the whole cycle one time. I'm sure you've like learned about that in this camp already. So yeah, it basically means that the entire model has been fed in. Sorry, the entire data has been fed into the model one time. That's what one epoch refers to. So the reason we have like different numbers for different epochs is because of like a training parameter we used called early stopping, in which, in a nutshell, we wanted to stop the model training if the model is getting worse. So yeah, essentially the LSTM model was getting worse after 14 epochs, so we stopped it there. CNN was getting worse after 19, and then DenseNet 121 was getting worse after 14, and ResNet was getting worse after 11. So we stopped the models before they get worse, basically. So we evaluate the model using these metrics: accuracy, precision, recall, and F1 scores. So the most important being accuracy right now. So accuracy, of course, the percentage it gets right is accuracy, very simple. So yeah, the methodology we used was like first pre-processing, in which we crop the images, and then we scaled the data, or also called normalization, and then we like code the data. Like no fire is, I think, 0 and fire is 1. Yeah, and then we split the data, test the models, make the models, test the models, and yeah, so that is what we did. That's like the coding aspect of our entire research. And these were our results. So as we expected, transfer learning did much better than CNN. Transfer learning, again, those pre-trained models, they did much better than CNN. And this is a graph. So the blue is CNN, yellow is LSTM. So we can see that LSTM did not do as well, which was a little expected, since LSTM is not typically suited for image data. And the green is DenseNet, which did the best, and red is ResNet. And if you see like purple is our base paper model, which we actually found a paper that used the same data set as we did, and they got like around an 84% accuracy. And we found that my research, the pre-trained DenseNet model, was able to achieve like a 96% accuracy, so significant improvement there. So moving on to our second research topic, which was demand response prediction in smart grids. So to understand the problem of the demand response prediction is that it is important to know the accurate demand for electricity. So essentially, each company supplies a certain amount of electricity to its like surroundings, and if the supply is too low, then we'll have an outage. There won't be enough electricity available for us. If the supply is too high, then the excess electricity will be wasted, which is something we don't want. So what we felt was that deep learning has the potential to accurately predict demand given previous data. So a slide about my data that we used in this research. It was from GitHub. GitHub is a very nice tool, not only for storing coding projects, but also, as I found, for getting data. So if you don't have GitHub already, I recommend all of you to get GitHub and use GitHub, especially if you're into coding at all. So the data ranged through 16 years, so it was a huge data set. It was real world data set from a company called PJMW, Pennsylvania, New Jersey, Maryland. It was PJM and W is just west. So there's a PJME as well, which is just east. So the way we used the data is we made it into sequences of 30 hours. So again, it was hourly data. So we used the previous 30 hours of data to predict the usage for the next hour, which is what we did with our data. So the models we used were CNN. So typically CNN is used for images, which means we would use two-dimensional CNN, but for this case we just use 1D because it's just timestamp data. It's not an image, so we had to use one-dimensional. We also used LSTM, long short-term memory again, which specializes in sequential data. So sequential data meaning when the order of the elements matter. It doesn't have to be timestamped, it doesn't have to be every hour. It could be your DNA sequence where the order of those things matter basically. So LSTM specializes in sequential data. GRU, gated recurrent unit, it was also used, and this also specializes in sequential data. And GRU is less computationally expensive than LSTM, but LSTM is expected to be your go-to model for sequential data. It's specialized sequential data is known to be really good in sequential data. So yeah, those were the models we used. And we also used linear models, and what we found was that deep learning is much better than linear models. The deep learning models we used were almost perfect accuracy. They did really, really well, but out of all of them, GRU was the best. So that's actually really good, since I mentioned before, GRU is less computationally expensive than LSTM, meaning that it can be used more feasible. It's more feasible, and the fact that it does even better than LSTM means that it's a good thing. It's better and it's less computationally expensive. So that was a very good result that we got. And over here is a graph of our results. So we use GRU to recreate the data to predict basically the entire data again. And the blue is the actual data, and the orange is the predicted data. And the entire graph is almost orange. That's because the GRU was so good that it overlapped with almost the entirety of our actual data. And if you can see, there are very, very tiny blue spots that, around there, which means that the GRU wasn't entirely 100% perfect, but it did really well. As far as I remember, it was above 99% accuracy, so it did quite well. So a little bit about the research I am currently doing, and then I'll wrap up my presentation. So first research I have been doing is related to cybersecurity, which I was introduced last year's camp. I'm using malware images, and I'm also using CNN convolutional neural networks, and I'm using them for multi-class classification. Second research I'm doing is, this one is actually my first research not related to CNN. So in this one, we're developing and analyzing social network platform for single parents. So I'm proposing this new social network platform, and I'm analyzing this proposed platform as well. I'm also using machine learning to understand the platform's effects. So I'm still using machine learning in the second one. The third one is related to gender bias in order to have ethical AI. So one thing that happens around us is that there are bias, not only gender bias, but racial bias and gender bias and a lot of biases encoded in AI. This can be due to training data having inherent biases present. This can be due to unintentional pre-processing techniques, which may accidentally influence the model to enforce some biases. So Yeah, gender bias for ethical AI is one of the research I'm doing right now. It's ongoing. So yeah, all of my research right now is related to AI, ML, and it's definitely one of my strongest passions. And the takeaway from this presentation is that me as a high schooler, I started off in the summer break after ninth grade as a rising sophomore to do research. And 1 year later is I have two papers presented in IEEE international conferences. So what I'm trying to say is that all of you can do research as well. It's not something you have to discover in college or something you have to start in college. So one thing that I would encourage everyone to do is find a topic that interests you and do some research on that. It doesn't have to be like machine learning or deep learning or anything that I've done. I chose to do research with deep learning because deep learning is a topic that interests me, but obviously not all of us will share that common interest. So find something that interests you. And one thing that I was worried about when I started research was that what if I'm unable to bring anything new to the world? What if I don't know how to contribute anything new? So if you feel that way, then there's also the option of doing a literature review in which you basically look at past papers. And in very simple terms, all you do, like, you look at the past, like a lot of papers, it's still a lot of work, but you look at the past many papers about a specific topic and you essentially summarize all those papers into one research paper. So that is one way you can go with a literature review. And that's all I have. Thank you so much for listening.